Hello everyone, and welcome back to the Winter Data Meetup. I hope you all enjoyed the insightful talks and discussions we had so far. Meet Meri Amirkhanian, a software engineer at EPAM. Meri will guide us through handling late arriving dimensions and early arriving facts. Plus, she will share 4 expert strategies for smooth navigation through changing dimensions. Now, before we dive into our next session, I'd like to take a moment to ask for your support in helping us grow our community and recognize the speakers. Firstly, if you are enjoying the content we're providing and want to stay updated on future events and talks, please consider hitting the like and subscribe buttons below the video. Now, for something a bit special. In the video description below, you will find a link to the talk page where you can provide feedback on this talk, give speaker a badge, and rate the session. Your feedback is incredibly valuable to us as it helps us improve future events and also provides recognition for our speakers' hard work and dedication. Throughout the talk, if you have any burning questions or insights you'd like to share, don't hesitate to type them into the chat box. Our team will be monitoring the chat closely and we will collect all your questions to discuss with the speaker after the presentation. And now, let's welcome our speaker to share her valuable knowledge with us. Meri, the stage is yours.
Thanks, Lizaveta, for introduction. Hi, everyone. My name is Meri, and today we are going to dive a bit deeper into the data engineering basics and, in particular, talk a bit more about strategies for handling late arriving dimensions. So a couple of words about myself. I've been working as a data engineer at EPAM for about 2 years, and my work usually involves ETL development using AWS services, integrating different data sources into our pipelines, and data modeling, part of which is the problem of late arriving dimensions. As for our agenda, we are going to start with introduction, where I will talk more about what is dimensional modeling, why the dimensions arrive late, and why is that a problem. Then we will move on to the 4 strategies for handling late arriving dimensions, where I will explain them based on an example, and we will finish with conclusions and Q&A. So what is dimensional modeling? Essentially, dimensional modeling is a common data modeling technique where data is organized into 2 main types of table. Fact table, where we store mostly quantitative data, facts that represent some business events or transactions, for example, orders, sales, purchases, revenues, and there are dimension tables that surround fact table and provide descriptive information that give us context into the data in the fact table. Usually in dimension tables, we have a primary key that also serves as foreign key in fact tables, creating the link between the two. We have 2 main types of schemas, star schema and Snowflake schema. Star schema is more simple. Here we have a fact table in the middle and a surrounding dimension table that provide different groups of attributes. And Snowflake schema is essentially an extension to star schema with more normalized dimension tables. So let's look at it more closely based on an example. So here we have a pretty simple star schema with fact sales in the middle. Here, of course, we have our primary key, sales ID, and respective 4 foreign keys. As for our 4 dimension table, so we have customer ID, we have promotions ID, product ID, and employees ID. Then total sales amount, promotion applied flag true or false, final amount after the promotion, and sales timestamp. And you can see in some of the dimension tables, we have repetitive attributes. For example, in team products, there are category name, supplier liaison. Liaison is the person who is responsible for contacts with that supplier. And for better data integrity and normalization, in Snowflake schema, those attributes would be separated into dim tables of their own. For example, we have here dim categories with category name. Here you could also add some more descriptive attributes about the category, and dim suppliers, where we have both supplier name and supplier liaison. Also in dim tables, you can see repetitive attributes such as manager name and department name, which can be separated into additional dim departments table, where we would have department name and manager name, and in result, in dim employees, we would not store directly the name of the department and the manager's name. They would be provided by department ID. So in short, Snowflake schema is more normalized, and thus it reduces the redundancy of data, provides better data integrity. Yet, as you can see, it makes the schema more complex and harder to understand. So if the querying is more important, the query performance more important, then maybe you should look more at star schema, as it will ease the query performance. In any case, the choice between the two schemas depends mostly on the nature of your data and the trade-off between data integrity and query execution. Let's move on to why do dimensions arrive late? So there are maybe multiple reasons for that, but let's focus on the three main of them. So first is, of course, data delays, when the systems and processes that generate the dimension data experience some delays due to some technical issues, for example, network connectivity issues, or there are some scheduled maintenance activities. Then goes, of course, manual data entry, when employees of the organization manually either insert or update the data in the tables. And this introduces delay reasons such as human error, employees' workload priorities, and approval processes. And lastly, we have data governance processes. When in some organizations there are more strict rules for data compliance and security that need to be met before the data is finalized and delivered. So this can, of course, also take more time if those validations take more time. Now that we know what are dimensions and why do they arrive late, let's talk more about why is that even a problem. So also multiple reasons here. First of all is, of course, data consistency, because late arriving dimensions can introduce inconsistencies to data sets used for analytics and forecasting. Also, it leads to discrepancies between different data sets, such as mismatched timestamp and attribute values. And then it makes it a challenge to reconcile the data. Then we have impact on downstream processes. So delayed dimensions also negatively impact downstream processes such as model training or analytics or forecasting. And these activities may be either producing their own output or be delayed, which also impacts the operational efficiency. Then we have data traceability disruption, when it's hard to follow the flow of data and the relationships between different data sets. And to reconcile, we need to take more troubleshooting activities, which leads us to increased operational costs, because whenever there is some problem, there is troubleshooting in place that requires allocation of more resources, and in long term leads to increase of operational costs. And lastly, we have compliance and regulatory risks, because again, in some organizations, timely reporting and data compliance are critical, and when there are delayed dimensions in place, it can expose the organizations to non-compliance and regulatory risks that may follow. All right, now let's talk about the 4 strategies for handling late arriving dimensions themselves. Now I will go through all of them briefly, then I will explain the data model of our example and the scenario, based on which I will talk about each of the strategy in more detail. So first we have never process fact, where we discard the record that does not have the respective dimension and just wait for another batch processing to happen that would bring us possibly both fact and dimension. Then we have park and retry, where we keep the dimension, the fact record without dimension in a staging table, and only push it to the fact table once the dimension arrives. Then we have insert a dummy value, where we right away insert the fact record into the table, but replace the missing dimension foreign key with a dummy value. And lastly, we have insert a row in dimension and later updated, often referred to as insert dimension, where we enforce the creation of the missing dimension record and then proceed with pushing the fact record into the fact table. Now here we have the data model of our example. So we have a gym that in its database has 3 tables. Fact orders is first of them. Here we record the orders of the services made by customers. And you can also see the respective foreign keys, customer ID and service ID. Also we have order price and order date. In gym customers, we have the primary key, customer ID, that again serves as foreign key for the fact orders table. Then there is customer tier, silver, gold, platinum, customer first name, last name, email, and phone number. In DIM services, we also have the primary key with ID, then service name, one-time entrance, one workout with trainer, 1 month membership, and annual membership, together with service cost and service cost currency. And in that gym, we have a situation when a new customer who is not yet in the customer table comes to the gym and makes an order, places an order for one-time entry to the gym. So the receptionist or another employee who is responsible for that only made the record of the order, but did not input the information about the new customer. So here we have the scenario of late arriving dimensions. Now let's look at the strategies of how can we fix that. Strategy number 1. Once there is a new record to appear in fact table, typically we check if the respective foreign key exists in dimension tables. If it's not, in the case with never processed fact, we just discard that record from processing. And as you can see in our example, I just crossed out that new record. And so we will wait for another workflow to run, and maybe it brings us the dimension record together with the fact order. But please note that the risk here is that if you do not do full loss from source each time, then there may be a situation that you only will extract this fact record for 1 or 2 days, and once you no more extract this record, only then after 5 days that dimension record will appear, and you'll end up in a situation where there is dimension but no fact for it. So let's look at maybe more safe strategies. So yes, but first of all, let's look at the step-by-step diagram to explain it in more detail. So first we have source data, from which we select the new and updated data, i.e. our delta. Then we apply the transformation logic to it and look up dimensions in dimension table. Whether or not the dimension is valid, we either insert the fact record into the fact table or discard the record from processing. As simple as that. Now we have strategy number 2, park and retry. So in similar case, when there is no respective dimension for our fact record. We do not discard it. Instead, we stage this record in a special staging table and wait for the batch processing when the dimension record arrives, and then we will insert the record into the fact table. The staging tables usually have same structure as the fact tables, but depending on the nature of your data, you may also want to add an additional column with timestamp or when that record was staged. Let's look at this step by step. So in this case, we have not one, but two sources of data. So first we go on with source data. As usual, we extract it, select delta, apply transformations, look up the dimensions, and if the dimension is valid, it's present in the dimension table, perfect, we insert the fact record. If it's not, then we insert the fact record into staging table. Then we move on to the staging table as source. We skip the steps of selecting delta and transformations because we've already done it. We move on right away to dimension lookup. And if the dimension did arrive, we insert that fact record and remove the fact record from staging table. If it still did not, then we leave the fact record in staging table. Then strategy number 3, insert the dummy value. In this case, we right away push the record into the fact orders table, but as you can see, it got inserted with a value of 5 zeros as dummy value because we do not have the dimension for it yet. In your case, the dummy value could be NA, null, unknown, 0. Most importantly, it should be consistent across all the cases of missing dimensions. And as the dimension arrives, you, of course, go back to that record and update it to the correct value of the foreign key. And as you can see here, there's also present fact order staging table, just like in the previous strategy, but maybe you can skip this step, but if you still introduce that staging table, this will increase the robustness of your system because, again, you may be extracting like only 1 or 2 last days of data from your system to save the costs, and once you no more extract that fact record and the dimension only comes after 5 days, then you can end up in a situation when you have dimension and a fact record with dummy value for that dimension. And at least in my case here, there is no key that would connect those two records. It may be different for your situations. You generate the key like in a different way, but you may consider also creating that staging table if you opt for insert a dummy value strategy. Now let's look at it step by step. So here we also have 2 data sources, but you can see that once you have 2 data sources, you can also concatenate them. Yes, so first on source data, we select the delta, apply transformations, and then concatenate it with staging table and look up the dimension. If dimension is valid and it's not staged data, we insert the fact record into fact table. If it's not, then we insert the fact record with dummy value for dimension for key and also insert the same record into staging table. If the staging, if the data in dimension is valid and it's a stage data, then we go on with updating the fact record in fact table and removing it from the staging table. And our last strategy for today is insert a row in dimension and later update it. Also, referred to as import dimension, where we enforce the creation of the missing dimension record with the data that we already have. In our case, it's only customer ID. All the other attributes stay null, and then insert the fact record into fact table. So in this case, when the dimension arrives, we only update that dimension record. And also, as you can see, I've added an additional column inferred flag with true or false values. This can also be a good idea to just notify end users about the fact that this dimension is incomplete. But we are waiting for the actual record to arrive into the table, and then we will update it. Also, again, let's look at how it performs step by step. So we extract the source, select the delta, apply transformations, look at the dimensions, and whenever it's there or not, we do insert it. But in cases when the dimension is not available, we create that dimension record prior to insertion. So that was it for the technical part. In conclusion, I can say that you need to have in place the strategy for late arriving dimension to have the data integrity in place within your data warehouse or data lake, and you also as well need to collaborate with business units to align the data entry and update, which will on its own minimize the cases of delayed dimensions. And also in collaboration with those business units, you should choose the correct strategy that fits the nature of your data, whether it be overwriting existing values or staging records. This all depends on the business requirements and analytical needs. And lastly, it's continuous improvement, because once you've developed the strategy for handling those late arriving dimensions, you should remember that it's an ongoing process. So you should constantly monitor, reevaluate, and refine your strategy so that it suits the ever-changing business needs, and also to be able to cope with use cases that you were not aware of, but they appear. So that was it for my part, and now I'd be glad to hear your questions.
Yeah, thank you, Mary, for the presentation. And let's move to the questions. The first question is, I didn't get difference between fact and dimensional tables. Do you mean that dimensional tables are smaller and fact tables are bigger and fewer?
Yes, exactly. So in fact tables are typically the largest tables, and dimension table have a function of providing the context into the data that is in fact tables.
Okay, thank you. Next question. Can I have only fact tables in my database without dimension tables?
You can technically, but this would mean that you store lots of redundant data in your fact table, and yes, it also affects the data integrity. So whenever, like, there are, for example, employees of the sales department, you may, while entering the data, you may make some typo, and instead of sales, like write sales with two S, or like, and it will affect the data integrity and the accuracy of data. So it's better to store that data in an additional dimension table and just refer to it by ID.
Yeah, makes sense. Thank you. The next question, a little bit maybe related. Does tables normalization make sense? Is it only reduce performance of queries? In Ho, it's better to have less tables. Normalization works only in theory.
Also normalization optimizes the storage of your tables, and also it assures the data integrity. So also, if you store too many attributes in your one-dimensional table, you can make a typo. So it's again, better to just refer to some attributes via ID.
Okay, next question. In first slides, there were dimensional tables referred to dimension tables. Does it mean that same strategies should be used for dimensions to dimensions?
So you're referring to Snowflake schema, right? So yeah, so whenever there are some repetitive attributes in dimensions, we should break them down into more dimensional tables, and again, it assures the data consistency and accuracy in our system.
Okay, and some questions about maybe testing of these tables. Is there any specific for dimension tables from data quality point of view comparing to other tables? Maybe there are some special checks or way of testing such tables.
The you may check it's as it's required by business, so you can refer rather to business analyst, and the best way to test the data in general is to make an example of data entry and then run it through the use cases that may appear, and then look at if the output complies with the expectation of how it should look from the business perspective.
Okay, and the last question. Looks like there should be regular data quality checks executed to validate if all late arriving dimensions arrived to have consistency data. For example, using insert dummy values, it will produce too many dummy values. How do solve it?
Um, you can solve it by aligning with your business units so that they ensure that the dimensional data arrives in timely manner, and then your scripts will insert it without having to add dummy values into your fact records.
Okay, so that concludes our session. We hope you found this talk insightful and inspiring. In the video description below, you will find a link to the talk page where you can provide feedback on this talk, give speaker a badge, rate the session, and download the presentation. Thank you very much, Meri, for coming, and to all who watched this video for your participation, engagement, and support. We look forward to seeing you at our next sessions. Until then, stay curious, stay inspired, and keep exploring the exciting world of data. Goodbye for now, and have a wonderful day.
Thanks, Elizaveta. Thanks, everyone, for joining. Bye.
Bye.